If you really love working with fractions, you could take an equation like the one we have here and go ahead and plug things into the quadratic formula where a is 1/4, b is -1, and c is 1/2, and do a bunch of squaring and multiplying, adding and subtracting and stuff with fractions. I generally would prefer to get rid of the fractions so I don't have to plug fractions into a complicated formula already. So here, looking at these terms, a common denominator for our fractions would be 4. 4 and 2 have a common multiple of 4. So we can get rid of our fractions here by multiplying every term in the equation, whether it's a fraction term or not, by 4. We would have 4 times -1/4 m squared minus 4 times m plus 4 times 1/2 equals 4 times 0. On the first term, 4 times 1/4 m squared is just m squared. Minus 4 times m, we have minus 4m. Plus 4 times 1/2 is 2. And then 4 times 0 is 0, like so. Now we don't have any fractions that we're going to need to plug into our quadratic formula. Here we would have a is 1, b is -4, c is 2. So let's solve this using those numbers in our quadratic formula. Here we'll have m, because m is our variable, equals a big fraction, negative parentheses, plus or minus the square root of a parentheses squared minus 4 times a parentheses times a parentheses, all that over 2 times a parentheses. B is -4, so we put that in the first two blanks. A is 1, so we put that in the next blank and in the blank on the bottom. And C is 2. So now we do the squaring and multiplying. The negative of -4 is 4. Under the square root, -4 squared is 16. Then -4 times 1 times 2, we have -8. In the denominator, 2 times 1 is 2. Subtract the numbers under the square root, and we have 4 plus or minus the square root of 8 divided by 2. 8 is not a perfect square, but we can split it up into parts so that we can simplify part of it. We can split it up into the square root of 4 times the square root of 2, and the square root of 4 is 2. So this gives us 4 plus or minus 2 square root of 2 over 2. This is one of those situations where both terms on top are divisible by the bottom term, so we just divide them by the bottom term. 4 divided by 2 is 2, plus or minus 2 square root of 2 divided by 2 is the square root of 2. And if we wanted to write the answers individually, we could write them as 2 minus square root of 2 and 2 plus the square root of 2. If you'd like to try the next problem on your own, pause the video now and resume when you're ready to see the solution. So for 6 and 2, a common denominator we could multiply by to get rid of the fractions would be 6. 6 times 1/6 x squared minus 6 times 1/2 x minus 6 times 1 is equal to 0. 6 times 1/6 x squared gives us x squared minus 6 times 1/2 x gives us minus 3x. And then we would have minus 6 is equal to 0. So here we'll have A is 1, B is -3, C is -6. Let's write x equals our big fraction, negative parentheses, plus or minus the square root of a parentheses squared minus 4 times a parentheses over 2 times a parentheses. In this case, b is negative 3, a is 1, and c is negative 6. The negative of negative 3 is 3. Under the square root, negative 3 squared is 9. Negative 4 times 1 times negative 6, we have plus 24. And then the denominator, 2 times 1 is 2. 9 plus 24 under that square root is 33. So we have 3 plus or minus the square root of 33 over 2. And there's really nothing we can do to simplify the square root of 33. Splitting it up into 3 times 11 wouldn't help because you can't simplify the square root of 3 or the square root of 11. So these are our answers. If you wanted to write them individually, you would write it once with a minus and once with a plus. Our solutions individually would be 3 minus the square root of 33 over 2 and 3 plus the square root of 33 over 2.